Hello again, everyone. So I'm here to talk about the story of cloud native, the good, the chaotic, and the kind of expense that would make your CFO sweat. But don't worry, it's not all doom and YAML. There's plenty to celebrate and a very exciting future to look forward to in 2025. And to understand how we got here, let's rewind back to 2013, where Docker came in and said, what if your code worked the same way on your laptop as it did in production? The technical revolution here was huge. Docker gave us consistent environments, and for the first time, developers could say it works on my machine without being laughed out of the room. And then in 2013, we also realized that containers are fun, but no one really had a clue on how to manage hundreds of them, let alone thousands, right? So we solved this problem by inventing an even bigger one, Kubernetes. In 2014, Kubernetes walked into the room like a superhero. I'm going to save you from all of orchestration hell, it declared, while quietly handing you 900 pages of documentation. And in 2015, we realized that the real innovation was Kubernetes' declarative model. You could finally tell the system what you wanted without micromanaging each step. But the downside was that if you got the YAML wrong, Kubernetes just said, sure thing, boss, and then quietly scaled your application to 1,000 replicas, taking down your entire cloud budget. So this was the year that we realized that great power comes with far too much responsibility. 2016 was the year of tools, and actually just more tools. Suddenly we realized that Kubernetes wasn't enough on its own. We needed Helm, Prometheus, and a whole toolkit of other friends. And then the ecosystem exploded, right? There were so many tools. But let's also be real, right? There were tools, but we also realized that we need tools to manage our tools. Helm charts for Helm charts, dashboards for dashboards. This was progress, but it also felt like you're calling your entire team meeting just to discuss about pizza toppings, right? 2017, this year, Kubernetes won the orchestration wars. This was a huge shift, right? Enterprises started adopting Kubernetes at scale. Cloud providers came in and offered managed services saying, don't worry, we'll manage it for you. And then they also handed you a 10,000 rupees invoice just because you forgot to delete a node group. 2018 was the year of observability. Kubernetes turned into this amazing mystery novel. Observability gave us all the clues, right? Prometheus told us the what, Jaeger told us the when, but the why was always missing. Debugging felt like piecing together all of this evidence, only to find out that the real culprit was always DNS all along. 2019 was the year of serverless, the year when we started running tiny functions on giant Kubernetes clusters. I'm not going to dive into this because everyone knows about serverless, right? There are no servers, or are they? 2020, the year of multi-cloud. Enterprises realized that one cloud wasn't enough, and neither was the budget. It felt like upgrading from one car to a fleet, which is very exciting at first, so many cars, but then soon you're drowning in maintenance costs, scheduling headaches, and you realize that you need a whole pit crew just to keep them on the road. 2021 taught us that our software supply chain is like a Jenga tower that's stacked high with the dependencies. All it takes is one library to crash them all. SBOMs and Sixtor gave us some tools to steady that stack, but most of the year was just frantically spent in patching Log4j versions before everything came tumbling down. In 2022, AI knocked on Kubernetes' door. So projects like Kubeflow made it easy to train and deploy models. This was a big shift, right? AI workloads are so resource hungry that Kubernetes had to evolve to handle this additional complexity. 2023, we realized that Kubernetes is actually very expensive. And as we managed to pay all of these bills, we realized that the real hero here was platform engineering. Instead of just throwing YAML at developers, companies started building internal developer platforms that made Kubernetes usable most of the time. 2024 was about maturity. We're now pushing the boundaries with AI, eBPF, and WASM. And Now, we're seeing the cloud-native ecosystem kind of settle down, but the challenges of navigating cost and complexity are still looming. And friends, that is where 2025 comes in. Now, complexity. It's kind of become like cloud native's last name at this point. Over the years, we've gone from, oh, containers are neat, to for the love of God, why that 47 YAML files for this single deployment, right? So this complexity is just going to keep increasing as we push forward. But here's the catch. It's actually not about just simplifying complexity. It's about how we manage it. The real question here is, how do we keep things running smoothly when complexity is the new normal? Now imagine the situation where you deployed a new version of your application and suddenly the pods start crashing. But you think maybe, no, it's just a fluke, but then you realize that the networking is down and the containers just won't start. So you dive into the logs trying to find out what is wrong. But it's like finding a needle within the haystack. And you know what? This happens all the time in production, and you're not alone if you're facing this. Kubernetes is amazing, but it's also the source of endless stress. You end up reading 10 different issues, make 5 different changes, only to find out that the real issue was a single typo in a YAML file. Right? But at least you learned something about YAML, right? And we've also ended up with a lot of platform fragmentation. You initially start out with a shiny Kubernetes cluster, excited about the endless possibilities, and then someone quietly comes and says, hey, have you considered using Prometheus for metrics, Istio for service mesh, Argo CD for CI/CD, and the next thing you know, you're managing 20 different tools, each with its own set of dashboards and a very different idea of what security means. I've also worked with teams that have spent months trying to get all of this to play nicely together, and it just feels like a game of whack-and-mole at this point, right? You fix one thing, then another one breaks. And it's just not a fun place to be in at all. Now, Aparna touched upon this in the last keynote, and she said that we're waiting for that Linux moment of Kubernetes. Right? Think about Linux. It's so incredibly complex, but do we really spend our days worrying about it? No, we just use it. So in cloud native, we want Kubernetes to be like Linux. It should abstract away all of the complexity, so you're not really focused on the ins and outs of leader election or what exact algorithm the scheduler is using. You just focus on what matters most, deploying applications. Now, backstage is solving one piece of the puzzle, right? It helps you build internal developer platforms, and it abstracts away some of the complexity through a centralized service catalog and a lot more other features. What we really need is declarative platforms, more automation, and more extensibility. What I should be able to just say, hey, I need a Kubernetes cluster, and then have one instantly spun up with networking, security, monitoring, CI/CD all configured and ready to go. Now, let's talk about what we're seeing in this ecosystem right now. What we're seeing is adoption tax. You know that feeling when you start out to say, hey, like, I'm going to build a platform, and then suddenly you realize, oh, wait, this is way more complicated than I thought? That, my friends, is adoption tax. The more adoption we see, the more this complexity is growing. And with this additional complexity comes cost. Right? Now, in the era of 2024 and beyond, every single rupee counts, and every pod could be your budget's worst enemy. And we're in this state where it's not like the move fast and break things era anymore. We're in the state of move thoughtfully, and for the love of God, stop breaking the budget era. And if you don't, your CFO could soon start replacing you with Excel macros. Oh wait, that's actually already happening these days. So let's talk numbers, right? 49% of the containers are using less than 30% of the requested CPUs. This is like buying a Ferrari just to go to the grocery store. Overkill doesn't even begin to cover it. And you've probably heard that you should set your requests and limits properly. Sure, but that's actually only half of the story. Kubernetes costs are like an iceberg. There's way more going on beneath the surface. Persistent storage, networking charges, even your NAT gateway are all lurking, just waiting to take a bite of your budget. So what do we need? What is the antidote to this fiscal chaos? Optimization. Real data-driven, ruthless optimization. How do we do it? So to find those inefficient pods, you can use OpenCost, which is a CNCF incubated project that breaks down costs all the way to the container and namespace level, so you know exactly where your money is going. Also, it integrates with all the other cloud provider billing APIs, adjusts costs in real time, and provides dynamic pricing. And the fun part is that it also plays nicely with Prometheus, so you can export all of this pricing data right into your monitoring stack. Now, let's take a moment to talk about autoscaling or cluster autoscaler. So imagine you have 3 nodes. The first node has 4 pods each, and the second and third node have 1 pod. Now, cluster autoscaler comes with 2 key tools. One is scale down utilization threshold, and the second one is scale down unneeded time. Big terms, but let's try to see what they are. So you can first think of like cluster autoscaler as the Marie Kondo of Kubernetes. If anyone's watched the show, Marie, if you're not familiar who Marie Kondo is, she looks at each node and asks, does this spark joy? If the node's utilization is less than the scale down utilization threshold, it's out of here, right? So it's time for a change. So it moves the pods to the second node and then gets ready to evict the third underused node. But just like Marie Kondo doesn't toss your sweater at first glance, cluster autoscaler also doesn't immediately retire a node. Here comes scale down unneeded time. So it's a grace period that basically tells how long a node can stick around, right? So the way this works is, so this timer decides like if there are new pods that are coming into the third node and this is within that timer, then that node will stick around. But if not, then it's just out of there. Now, let's go to a Kubernetes food festival. And that's organized by Cluster Autoscaler's feature called Priority Expander. So Priority Expander, since it's organizing this food festival, decides to get which dishes can be present here and which dish gets the most attention and resources. So first up, we have biryani. It's the star of the show because be it Hyderabadi, Lucknow, or whatever biryani, everyone just loves it. So it gets the premium spot. This represents your high priority scaling group, which gets it's all about the top tier workloads getting the best resources. Next up, we have fried rice. It's adaptable, flavorful, always a cloud favorite. But again, not everyone likes Indian Chinese food, so it gets the medium priority scaling group. So this is the group which mainly has a respectable number of resources to keep everything running smoothly. And finally, we have misal pav, my personal favorite for Maharashtra. It's very spicy, but again, not everyone can handle the spice, so it doesn't get the fancy treatment. This represents your low priority scaling group that just keeps uses the less number of resources and just keeps things running smoothly. Now, here's where priority expander shines. Right? If one day misal pav suddenly becomes popular through an Instagram reel, Cluster Autoscaler will immediately shift resources and then make it the centerpiece. So Kubernetes ensures that each dish gets the right spotlight at the right time and avoids an overcrowded food festival. Now, we talked a lot about Cluster Autoscaler, right? And it's great for predictable workloads, but it's also just a little basic. It follows orders. And it adds nodes based on a predetermined size. So this also means that if your node is too huge, then you end up paying for unused capacity. If your node is too small, then you need to add more nodes, and then the costs rise. So to solve all of this, there's Carpenter, the next-gen tool for Kubernetes optimization. While Cluster Autoscaler just adds nodes, and follows orders, Carpenter takes a more dynamic approach. It doesn't just add nodes, it decides which nodes to add, how many, and what size. If you enable the consolidation feature of Carpenter to true, it will do exactly what the Cluster Autoscaler does, but it also ends up looking for cheaper and more efficient resources and instances to spin up. So let's go back to our initial setup. So in this case, instead of evicting the third node and moving the pod to the second one, it actually spins up a cheaper instance and moves the pods there. So we can see that better utilization of worker nodes in this case means reduced costs and better efficiency all around. Now, let's talk a little bit about networking costs, right? Networking costs are so annoying, they're so unexpected, and it's like the roaming charges of 2000s. So if it makes sense for your use case, try to keep the pods and data in the same region to avoid Kubernetes version of international calling. Now, logging is great for debugging, but if you store everything forever, you're gonna wreck your budget. Kubernetes doesn't need to know every 200 OK response that you've ever received. Right? So be smart, set filters and policies, and keep it lean. So friends, optimizing for Kubernetes isn't just a good idea, it's a survival strategy. If you don't do that, your CFO could soon slide into your inbox with an email that says necessary budget changes, and they won't be talking about scaling cloud resources. They'll be talking about scaling down you. So with all of this knowledge, we know that as we look into 2025 and beyond, the future of cloud native is shaped by complexity and cost. There's a lot to do, but with all the innovation, the energy, the passion, the ideas that we have in this room, we're more than ready to tackle it. So let's get started, and thank you very much.